Okay, welcome everybody. I'm Justin Cormack, this is Nassim. We work in the security department at Docker, and we're going to talk about making security controls understandable so that users can actually work out what's going on with security. Container security is often viewed as a really kind of complicated subject, a sort of maze of difficulty, and we'd like it to be kind of something, security should be something simple, like just putting your finger on your iPhone to unlock it. You know, that comes with a set of security guarantees that are designed for the situation in hand, and making security that's not usable is a really difficult because it's not actually particularly secure. You have all these different security controls in containers, and you may have come across them in the documentation, and maybe you know what they are, and maybe you understand what one or two of them do, and but it takes a lot of effort to actually understand in detail what they all are. And so if you ask a developer, make sure your container is securely configured, they don't really know how to apply all those controls to it. I mean, this is the help page for Docker Run, and it's just got a ridiculously large number of options. There's a comment on, I think, on the ls man page in Linux saying bugs has too many command line options, and this kind of has almost that many. And so, you get into the details of what capabilities are. Capabilities, for example, are different ways of dividing up the root permissions, the permissions of the root user, so you can make more fine-grained control. There are 40 of these. They can't be more than 64 because of the number of bits that's been allocated in the kernel, and so everything tends to get lumped in as capsys admin, a special capability that lets you do pretty much everything. Some of them have kind of more understandable things, like you can insert modules into the kernel, but a lot of them are in these kind of overly broad boxes. Namespaces are the pieces which we make containers out of, and cut down what you can actually see inside a container and what names you can reach. But again, there are like 7 or 8 of them, and they're kind of complicated to understand and deal with, and it's very unclear for a general user what the security properties are, and there are some combinations of capabilities and namespaces that will let you escape from a container and other ones don't. Setcomp, if you look at the Docker setcomp policy, which we spent a lot of time working on, it's a very, very large JSON file that is extremely long, and it could usefully do with being even more complicated, but for various reasons it's not. But it's very difficult to write, and people who try and modify it soon get very frustrated. Then you have AppArmor if you're using an Ubuntu or Debian type distro, which is a whole security policy set on top of all that, which lets you constrain many of the same things, but in a totally different language. So if you want to sit there and write these policies by hand and feed them into the command line in Docker or Kubernetes, it's just going to be a total mess, and you're just going to kind of sit there and read this, and your head's going to explode, and you're going to say no. So, and then you're going to say, well, I'll just use minus privilege because that works for everything. That's perfect. And that's really not ideal. So the aim of this kind of talk is to talk about some proposals for doing this in a better way, and Nas is going to talk through some details. Have a clicker.
Yeah, so can you hear me well? Okay. So the idea was to actually provide something that actual human beings can understand without having to dive into any type of code, possibly without even checking the documentation with a explicit enough mechanism. And this is why we decided to try at least to introduce the Docker entitlements, and hopefully the Kubernetes one that we are currently working on. And so, yeah, we're going to go through the solution. So the proposal is basically providing the ability for users to actually specify, to choose between a very simple set of permissions on the CLI when they want to run a Docker container, but also a Kubernetes pod. You have to make sure that the users focus on what makes sense at their level, right? They don't need to understand the kernel constructs and how the namespaces interact with such capability because someone did a hack in the kernel at that point and blah, blah, blah. People don't care about that. People want to make sure that their app is secure and that they can easily explain why they decided to create such a security profile for their app. So we decided to divide these permissions into resources or domains that make sense for end users. So basically the network, should the network access be completely confined? Does my container or pod need to a very simple like user type of network access? Is it a proxy? Is it a full admin? Same thing for security, and also same thing for host resources, so devices, for example. And yeah, that's basically it. You should have to choose between a very simple set of permissions. So I proposed that to Obama. He answered that it would make sense. This is his face, so I guess we did a good job there. The thing that is going on behind the scene is as simple as you would expect, is basically the job of the platform to handle all the translation. Making stuff simple is the work of, is basically the work of people who work on Kubernetes, Docker, the different runtimes, abstracting the complex stuff is not the role of the user themselves. So behind the scene, when a user will say, "Hey, I want my container or pod to be completely confined," so it makes more sense for a container. You would actually enforce at the second level, which is a syscall firewall, basically. You would want to prevent any operation on network sockets, but making sure that the Unix socket still works, so you can actually do regular actions. Making sure that the AppArmor profile adds restrictions on the network capabilities. Same thing at the kernel capability level, tuning the path that a container has access to, and so on. There are various things. Of course, this depends on the Linux security modules that are supported, and various things. But it should be the work of the platform to make it completely abstracted for the end user. Same thing for an admin. An admin is basically, a network admin is basically the same level of privilege as proxy, but would have additional very sensitive network capabilities. So CapNet admin, being able to do even more network packet inspection, and so on. But there is actually more to do, because you can provide the user some simple set of permissions, but we should also leverage the knowledge that the developers have on the application that they are creating, right? So they can pass along informations to the people, to the operations people who are going to run that into production. So here it's a Docker build, but any image builder and image signer should do the trick. Basically, if you take your image and the list of entitlements and you bake that into, you create a bundle that ties the two together, you actually get an image with its own security profile that is independent from the underlying machine. If you decide to sign that, you actually get a trusted bundle that content publisher can actually deliver to the end users. Because, for example, if I want to run Nginx with the best sandboxing environment, Nginx people are certainly the best people to actually do that. They have all the knowledge about what is going on behind the scene inside the application, and I would want to run the application with the best advertised security configuration possible. So that's the idea. Mobile platforms do that for applications. Even macOS and Windows do that. We should be in the container ecosystem be able to actually have trusted security profiles along with the images. So quick recap. So that's basically the Docker build. So on top, that's before, and below the line, it's with the entitlements. So before, you would just run your Docker build and get an image. With the entitlements, you get your security profile, you sign it, and you get a trusted bundle. After that, you can, as a user, you can pull the image, run it. It will be non-sandbox. You will have to dig into all the security stuff yourself, and good luck, because it takes a while to make the right decisions. With the entitlements, you pull your trusted bundle, and you get instantly the best protection, the expertise by the content publisher, and also the support, because if there is any vulnerability that shows up in your application, I also don't want to go monitor every single vulnerability. I would want the content publisher to take care of updating the security profile for me in order to block the vulnerability if possible. So key goals of this is basically providing the best user experience possible. This is really the goal number one. We need to make sure that people use the security options available, and we want the end user not to opt out of the security configuration if they get permission denied for some reason during running the application. We also need to empower the people who write the application themselves, right? They have the knowledge on the application. We need to provide them a way to easily understand what are the permissions that they can hand over to the people who are going to to deploy that in production and maintain that. If possible, we would like to create a standard that would be widely adopted, so that all the platforms and all the that supports all the platforms, all the operating systems out there. So yeah, basically Kubernetes, Swarm, any other scheduler that people want to create. That'd be great if we were to actually provide security profiles along with images that can run on any single platform, and would be translated into low-level bits the way the platform understands them. And yeah, we really want to make sure we ditch at some point the privilege flag, because this is really a bad habit. Yeah, it basically disables most of the sandboxing that you create around the container, and it leaves the packaging feature and a few security guarantees, but pretty much everything else is disabled. Also, security is often about least privilege principle. You want to give the least, the smallest amount of privileges that an application needs in order to run properly, right? And this is not the case currently. Currently, everyone runs with defaults that work for 98, 95% of the applications out there. And that's just not possible because you are still giving the ability to use like a way too big attack surface. You're allowing syscalls that are not used by applications access to the paths in the file system that shouldn't be needed in plenty of applications. This is really something that needs to be fixed. And yeah, we need a way to create actual security profiles along with images that we can hand over to people who want to adopt and that might be scared about the security aspects of containers in general. Yeah, we will also have various stretch goals, such as allowing people to create custom entitlements, because it's always hard to come with a set of permissions that fit everyone's needs. This is something that will need to be discussed. API access control and service-to-service communication control, basically maybe providing a way to say, hey, this container or this service should only be able to talk to these kind of services the same way as, for example, on iOS, you can say this app has the right to talk to only these daemons. Yeah, basically the idea to have the directly inside the security profile information on which service does your app has the right to talk to. And yeah, if you have any additional ideas, this is still a very open discussion, and we need everyone to participate to make the better out of the entitlements. So who's down for a quick demo? No? Yeah. Everyone is sleeping? So I'm sorry, we didn't have time to have it work on Kubernetes, so it's gonna be on Docker, and we needed to actually implement that inside Docker first in order to provide a base mechanism, basically, for Kubernetes in our own environment. So we'll try to run our Nemesis, which is Docker in Docker. Docker in Docker needs a lot of privileges, accessing security file system, mounting the C groups, having privileged access to the interfaces, various level of privileges. This translates into if I were a developer writing the Docker in Docker, I would need network admin, because I know that I do sensitive work on the network. Security admin, because I need an admin permissions on the security file system. And I need also admin access on some of the host resources. So let's run the Docker in Docker with these three entitlements rather than the privileged or, yeah. So this is basically running a Docker daemon. And here we'll just exec into it and check that it works. So we'll just run an Alpine just to make sure that everything works great. Good. Right. Yeah. Sorry, Alpine people. That was against you. And yeah, so here we are inside the Alpine, inside the Docker in Docker. And now we'll just run a Docker update just to see. Yeah, we can fetch everything. So yeah, that's basically, we have network capabilities inside the container. Everything is working great, and we didn't have to actually disable all these second profiles, all the AppArmor profiles, and everything. So now we're going to switch to the second part of the proposal, which is basically building an image with the entitlements inside it, so that end users can actually run a container without respecifying all the security stuff again. So if we inspect the image that we just created, by the way, the image is just from Docker in Docker. So if we check, the entitlements are actually inside the container config, inside the image itself. And if we want to run it without any additional security options, it will work again. That's amazing. So I exec into it, same thing. Just to make sure that you trust me. I'm not a liar. Okay, sounds good. So yeah, it's basically the ID. And as an end user, I would just pull the image, the trusted image, and run it. So of course, you should have a way to specify if you are trusting this content publisher. But yeah, the idea is I don't want to run, I don't want to dive into the documentation, etc. Everything is provided by the Docker in Docker people. So yeah, that's basically the ID. And is it this one? So yeah, this is the exact same behavior that we want to achieve on Kubernetes. So making sure that people can run through kubectl and deploying pods with the best security configuration right away. Yeah. So what about Kubernetes? Yep, sorry. Kubernetes has the same usability issues. The security features from the security context and the PodSecurityPolicy map pretty much one-to-one. So even though it's in alpha right now, and which means that it can be more or less changed a bit, it's still not great for people out there. So and there is no way to advertise the best security configuration for a pod. So that's the idea. So where would the user input happen? Basically, it would most likely happen either through the security context itself, that would be extended, or through an admission controller, which would prevent from having conflicts, basically, between the second profile that is provided inside the security context and the one that would be generated from the entitlements themselves. There are still discussions also if we want the entitlements to be additive only, or if we want to actually restrict more than like set a default and then allow the ability to restrict more. And yeah, we sure don't want to break the security context format, so this is going to be TBD. And if we want to provide the security profile along with the image and have people run pods directly with this security profile, we need to provide a mechanism to actually inherit the entitlements from the image. So yeah, this is something that is work in progress in the Docker builder, so that directly inside the Docker file you can inherit entitlements. But you should be able to directly through the admission controller to specify that you want to inherit the entitlements. And yeah, for the translation into low-level bits, currently in Docker, it's basically keep security options in the form of entitlements as much as possible, and then the translation into low-level bits is done right before handing over to containerd, and then to run C, creating the container basically into OCI specs. Again, the admission controller would be the best place to create that, to do that. So if you have any opinion, feel free to share your opinion on the libentitlement repository. Yeah, so I'll leave you to the next slide.
So yeah, so we got a bit of work to do to integrate into Kubernetes. I just want to talk a little bit about some of the kind of pain points as well. I mean, I think that there's still a bit of work to do to define standards and work out kind of how different rules work together. There's particularly setcomp is a real pain to work with to do complicated policy stuff. And eBPF-based learner security modules are something that's been talked about for quite a long time. and actually would make it much easier because you get a lot more kernel context to actually make security policy decisions with eBPF, because you get to know things like what file you're trying to open and what kind of file descriptor you're working on, things like that. And that would make it much easier to deal with kind of conflicts between different types of policy that want to restrict the same system calls. There's been a bunch of work on that with landlock and checkmate, and those are kind of actually progressing quite a lot recently, and I think that's a really important area to look into to be able to write more detailed policies. gvisor was announced, obviously, which is emulation-based, but the thing is that while it locks your stuff down a lot, it won't actually let you do host privilege operations. So if you really want to do something like running sidecars, debugging, things where you really want to actually control stuff, you still obviously need to set real capabilities and run real stuff, and so this is more useful. But if you just want to really lock things down, things like gvisor or really restrictive policies are what you want. Open Policy Agent is a really nice project. If you haven't looked at it yet, there's been a bunch of talks today, over the last few days. Definitely worth looking at. It's a really nice way of writing policies, but you still need something to define what the user understandable things that you're going to write those policies over are. But it would be nice to look at integrating the two, because it's a really nice framework to use, and definitely recommend it. Stuff's in the repo. Please come and have a look and give us feedback. And I think we've got a little bit of time for questions, probably just very briefly. If we have got time for questions? Or, yeah, we got. Any questions?
Can you repeat the part about how does it compare to OPA?
It doesn't compare to OPA. I think you could use OPA in order to write the policies, to write more complex policies, but still over simple entitlements rather than, the last thing you want to write a policy about is, say, you don't want to write an OPA policy over an entire seccomp policy, because although it's technically possible, it's still the horrendously complicated seccomp policy that you don't really want to try and reason about at that level. Because yeah, technically, and I have tried this out, you can technically write OPA policies directly over seccomp policies, but I wouldn't recommend it.
Any question?
Okay, well, we're around, dude.
Sounds good.
And thanks very much.
Thanks, everyone.